Hi guys, it's part 2 of Unit 7 pretest systems of equations and matrices. So let's go get to problem number 9. There we go. During our last week, the owner spent $91 on 15 gallons of milk and 11 pounds of butter. This week he spent $70.40 on 12 gallons of milk and 4 pounds of butter. So let's just set it up, 91.25. I'm going to write it the other way. I'll put the equals part. So 15 milk plus 11b equals 91.25. And then we have 12m plus 8b equals 70/40. So the matrix that I'm going to be working with is this 15, 11, 12, 8, 91.25, 70.40. And we want to know what m equals and b equals. So I'm going to go ahead and use Kramer's rule because it's easy-ish. Okay, so my m is going to equal the determinant divided by the determinant of the first part, 15, 11, 12, 8. I'll change the x column because that's your m column, 91.25, 70/40. And then you leave the y column in 8. Then I'll go ahead and put the b column as well. This one is 1512. And this is 91.25 and 70/40 all over 1511, 12/8. So let's work them out. Using a super cool calculator. Make sure you do good calculator stuff, okay? Otherwise your life is ugly. So we multiplied and we're going to subtract the other multiple. And we're going to multiply, so that is 120 minus 132, which equals negative 44.4 divided by negative 12, which equals 3.70 because we're dealing with money. Oh, that was kind of weird. It's a divide line, by the way. So let's go write our information over here. So this is 370. Milk is 370. So hopefully you guys get really good at Kramer's rule, because if you could do Kramer's rule, your life is a little bit easier. You can solve equations by elimination if you want to as well, but it's not easy or ish. So here we're going to get 1056 minus 1095 all over negative 12, because we already knew that. So negative 39 divided by negative 12 equals 325. So that's my butter price. Ooh, I cut that off. Butter price is 325. Okay, so this one here, if my determinant equals 0, then you can't have an inverse. So we don't want it to equal 0. So then we're going to do multiply. So negative 36 minus a negative 4n squared cannot equal 0. Solve for n. So add 36. So we have 4n squared equals 36. Divide by 4. So then I have n squared equals 36. Oh, not at all. 9, good, it deleted itself. And then we're square root both sides. So n, and we don't want it to equal, right? Don't want it to equal. Cannot equal plus or minus 3. If it does, then you can't have a number. Okay, now working with partial decomposition, the first thing you need to do is you need to factor that. So that's x plus 3, x minus 1. And then you're going to rewrite your equation, and I'm going to work on the whiteboard for that. So I have 2x plus 10, or is it negative 2x, all over x squared plus 2x minus 3 equals a over x plus 3 This is getting annoying. Plus b over x minus 1. I know you guys can see what I'm writing. And then my LCD is x plus 3 times x plus 1 minus 1. So I'm going to multiply everything by my LCD. So stuff is going to schnick. Those schnick. The plus 3s with the a schnick. So then you're left with negative 2x plus 10 equals ax minus a plus bx plus 3b. Okay, then the next thing that you're going to do is you're going to group parts together. I'm going to have my 2x equal my x's. So I have negative 2x equals a plus b. So that means that negative 2, divide everything by that, equals a plus b. And then we'll go ahead and do the coefficients. Not the coefficients coexist by themselves. So 10 equals negative a plus 3b. So with that bit of information, I'm going to write it down so I don't lose it. So I have a plus b equals negative 2. Then I have negative a plus 3b equals 10. Okay, so my augmented matrix for that would be 1, 1, negative 2, and then negative 1, 3, and 10. So I'm going to go use Cramer's rule to help me solve this. Okay, so A will be the determinant at the bottom is the same for both. 1, 1, negative 1, 3. B, denominators can be the same. The numerator changes. The x switches to be negative 2, 10, y column is the same. X column is the same, y column switches. Multiply negative 6, multiply minus negative 10, multiply minus a negative 1. So this is negative 16 divided by 4. So A equals negative 4. Multiply, we get 10 minus a negative 2 all over. We decided that was 4 already. So this is 12 divided by 4. So B equals 3. So what that means is my partial fraction will be a negative 4 divided by Ooh, I better find out. And then plus negative. Oh, it's something went wrong. 10 minus, oh, okay, I screwed up somewhere. Good thing there's multiple choice answer. It's going to be minus positive, so that's going to be 8. So this is 2. So B is 2. Plus 2 divided by, gotta go back one page to see what I put over my A. My A was over x plus 3. And my 2 was over x minus 1. So that means that negative 4 is over positive 3 and 2 was over my minus 1. So my answer is B. Sweet! This ones are kind of hard. So let's do another one for fun. Okay, my factor parts are x minus 5, x plus 2. So I'm going to write out my partial fraction over here so I kind of don't lose it last time I lost it. Cool. So let's go to the gray board. So I have 5x minus 41 all over x squared minus 2x minus 15 equals a over x minus 5 plus b over x plus 3. Your LCD is x plus 5, nope, x plus 3, x minus 5. If I multiply everything by LCD, it'll schnick on this side, and then x minus 5, x plus 3, this one x minus 5, x plus 3, x plus 3 schnick, x minus 5 schnick. So I get a x plus 3 plus b x minus 5. Multiply it through. Do your grouping parts. So 5x equals ax plus bx, which would be 5 equals a plus b. Do your secondary grouping, negative 41, 3a, negative 5a, negative 41 equals 3a minus 5b. I meant to say b. I'm losing my brain. So let's rewrite it. A plus b equals 5. 3a okay, and then let's rewrite our augmented matrix so we know what we're working with, and then we'll come back. So I don't want that there. So our augmented matrix is 1, 1, 3, negative 5, 5, negative 41. Let's go play with Kramer's rule. Ready? I am. X column switches. Y column stays the same. And for B, and let's crunch our numbers. Negative 25 minus negative 41. All over negative 5 minus 3. So this equals 16 divided by negative 8, which is negative 2. So A equals negative 2. And let's switch colors. This is negative 41 minus 15 all over negative 8, which is negative 56 over negative 8 is 7. So B equals 7. So I did a little better job of keeping track of my stuff. So A was negative 2, B is 7. So then negative 2 over x minus 5 plus 7 over x plus 2. There's your answer. Okay, these ones are cool. What we're looking for is we're looking for the points of intersection, and then we'll plug them into our original spot to see which one gives us a bigger one. So if we're looking at x is greater than 0, that would be on this side of stuff, right? When we're looking, so that was x is greater than 0. And when we're looking for y is greater than 0, that would imply this side of stuff. Whoops, I should have done it a different way. That implies that side of stuff. So far, we're in this box here. Okay, but when I have x plus 8, or x plus y is less than or equal to 8, I'm going to go by 2s. 2, 4, 6. Oh, I could probably go by 1, 2, 3, 4, 5, 6, 7, 8. I can do this. 1, 2, 3. So this line here. And so far, we're in this triangle here. Okay, I just totally made things all murky. So let's delete everything and redraw it. Oh, I need that one to be better. No, it'll work. It'll work, because so far we're under here. And then let's go and figure out how to do this one. Whoa. This one. If I solve for y, I get y is less than or equal to 1, negative 1/6 plus 4. So we're going to start at 4, 1, 2, 3, 4, x. I'm going to go down 1 over 6, 1, 2. So my critical points now become this one, and this one, which is 0, 4, and this one is 1, 2, 3, 4, 5, 6, 6, 3, and then this one is 8, 0. So I'm going to plug all those in. So I'm going to go use the other board over here. So I have 3x minus y. If x is 0 and y is 4, then I have 0 minus 4 equals negative 4. So that was one option. If I have 6 and 3, then I get 18 minus 3, which is 15. So that's one option. And then if I pick 8 and 0, then I have 3 times 8 minus 0, so 24 minus 0 equals 24. So which one gave us the biggest value? It was the 8 and 4, and the biggest value happened to be 24. So C. Cool. 2 more problems, guys. That's it. Okay, so this we're going to do similarly. Okay. I'm going to do this one first. 1, 2, 3. And we want to be below it. Then let's do this one. We want to be above x equals y. And then let's do where we want to be bigger than y. And then we have one more stipulation. It's 5, 1, 2, 3, 4, 5. Oh, I totally did those ones backwards. Didn't matter. As in my graphing, but I did them the wrong way. My yellow, anyway, my yellow and my green. So where are my critical points? My critical points are 0, 0. This one, 3, 5. And then this one, 8, 0. So going over to the gray board, I have 2x minus y. So we're going to plug in one at a time. I'm going to do 0, 0. If I do that, I get 0 minus 0 equals 0. What if I plug in a 3, 5? Then I get 6 minus 5 equals 1. And then if I plug in a 8, 0, then I get 16 minus 0 equals 16. So guess what? 16 is my answer. Eight, 0 leads me to 16. Oh, the minimum value. Oh, asked me a different question. And I so need to, like, you guys didn't stop me. That was crazy. How come you didn't stop me? That green one's wrong. Green one should have been 0, 5. That would have been 5. And this would have equaled -5. And it asked me for a minimum because I finally went and read what I was looking for. It says minimum value, find the minimum value. The minimum value is going to be -5. Okay, always good to read the question when you answer it. Phew, I read it. So let's go to the bakery. This one's going to be a little weird to figure out. So we're going to do C, P, cupcakes and pies. So I'm going to change my X to be a C and my Y to be a P so I can graph it. So these are all my equations. C plus P has to be less than or equal to 100. So what that means, we're going to do, this is 100, there's 100, we'll pretend. It's got to be less than 100. Okay, and then the next critical point is that cupcakes is going to be less than or equal to 70. Here's my cupcake, so we're going to go 70. And then we're going to do our pies have to be less than or equal to 60. We'll call this 60. So we could begin to see that our shaded region is from here, there, there. We got 4 points that we got to check out. So this is 60, comma, 0. I'm having issues here. This one is 60, comma, 60. Can't be 60, 60 has to be 60, 40. And then this one is going to be 70, 30. And this one is 70, 0. So we have 4 things. So P plus C, I better do C plus P. Has to be less than or equal to 100. Okay. But we have, how much are our cupcakes? $1.50 times our C plus 600, $6 times our P. So what's that going to be? If we have 60 cupcakes, wait, that one's, I wrote them wrong. Over here, I wrote it wrong. 0, 60. So if I have 0 cupcakes and 60 pies, and then I have 40 pies and 60 cupcakes, and then I have 70 cupcakes and 30 pies. I wrote it right on 2 of them, and the other 2 I didn't, and 70 and 30 and 0. Okay, so those of you who are thinking I was doing something stupid, I was. That one's wrong as well. Okay. I wish you guys could be with me live on these webinars, but you're not. So then this is 1.5 times 0 plus 6 times 60. So this is going to be 360. Okay, so if we do 1.5 times 40 plus 6 times 60, it's going to be 60 plus 360 is 420. And then this one I'm not going to be able to do in my head. I'm going to have issues with doing it in my head. So if we have 1.5 times 70 plus 6 times 30, pull out a cool calculator. Did all the other ones by calculator before I did it, but I forgot to crunch these numbers because they're just cool. So 1.5 times 70 plus 6 times 30 equals 285. And then if we only do cupcakes times 1.5 equals 105. So where we're going to max out, what's the maximum value of baked goods she can produce in 1 hour is $420. That's pretty good if you're only one person, but if you got like lots of people on your staff, it's not very good. Oh, I'm done. Bye, guys.